you really, at least for 10 minutes. You can do 10 minutes, okay. No
So
big
let's
deal.
use on the version.
Yeah. I don't think they can do it in 5 minutes.
Yes.
Definitely it's not going to
So
take 15 minutes.
we have two versions of slides. Did you upload the second version?
I only got, I don't think I got the second one. So we get started.
Probably we should start.
Yeah.
Good morning, everyone. Welcome to Dublin, to Routing Working Group meeting at IETF 121, and we are about to start. We've got interesting agenda for you. So not well, please make sure you've read not well, you understand your contributions to IETF, and you're familiar with all the documents mentioned here, all the BCPs. We have no new RFCs since IETF 120. We've adopted the VRP update, so now it's working group document. There are two drafts that have been submitted to publication. The routing to ILFA, we need a revised ID. So we are pending approval from the ISG. It's today on agenda, so you'll see the updates. And the net cloud problem statement has been returned to working group, and the authors need to review and address ISG comments. Working group document, BGP peak, more work needs to be done before the second working group last call. It's on agenda today. So thanks for authors to working on it. The QoS model, it's expired. Guys, we are looking for new editor. If someone wants to volunteer, we would appreciate it very much. A lot of
People who understand QoS or people who is interested in doing young model, you are welcome to volunteer.
So a lot of work has been put. It's really complex topic because each vendor has different QoS model. So it took years to really align, and we are very close to finishing it. Please do help us. And point to multipoint BFD, the authors, among which I'm so Engine will be progressing the draft. The authors believe that it's ready for working group last call, so we'll pause the working group post ATF on your opinion. Agenda for today, I'm not going to read it. So the most important topic of today is rechartering. It's been a really long time since we didn't touch the charter because it's what we are working on. But now is the time really to include additional work that we've been doing. And so pretty much we are trying to formalize what we've been doing for the last probably 2-3 years, right? So what you see here in large and in yellow, those are the new topics that we wanted to formalize. So besides usual statements that we work on routing related stuff that is related to fast convergence among routing protocols, work that doesn't fall in any other routing area working groups, work on YAML models that is not, again, in scope of particular working group. We include satellite routing. There's an ongoing work. We had a number of presentations. And there's routing in data centers, which we started here in 2017 probably. And we've got Rift and LSVR by now, but we will continue. There's innovation going on in the industry, so we are the hum. And then the last one is networking within AI clusters, which is reasonably new work. It has become really, really large topic in industry last year. So half of the presentation are related. We know that networking in the AI class is very important. It's growing exponentially every 6 months. So we'll continue working on it, again, driving innovation and industry alignment. Please do review the recharter. There is also parallel process in ISG to approve it. So we'll appreciate your opinions. It's a good tradition by now. We are having AIDC side meeting on Thursday at 3 p.m. We finally finalized our agenda. It's really exciting. We are getting industry leaders to talk about what they're doing. Some of them are going to talk for the first time about what they're doing. So, hey, join us. We will publish the formalized agenda later today. We've got Google, Meta, and NVIDIA talking about their work in AI networking. And we are ready to start.
Go back to the charter. If anybody have some comments about the charter right now, you can speak up. Otherwise, we'll go to the agenda items. You can send your comments to the list later also. No?
Okay.
Ahmed, are you there yet? Here yet?
Yeah, I'm here. Can you guys see me?
Yeah.
Or I'm not seeing. Can you guys hear me? Actually, I closed my camera. Can you guys hear me?
We can hear you.
Okay. So thank you very much. This is slide number 1. I'm going to talk about these 3 slides, actually, these 3 drafts. I'm going to talk mainly about the first 2 drafts, as Jeff mentioned. Next slide, please.
You have control of the slides.
Oh, I have control. Okay, excellent. Okay, that's good. Okay, let's see if it works. Okay, excellent, it works. So very brief memory refresh. So the first one, the TILFA draft, it leverages segment routing to provide local protection against failure or unplanned failures of a link, a node, or a single SRLG. BGP PIC basically talks about forwarding data structure by proposing organizing them in a hierarchical and a shared manner, so that traffic can be rerouted to ECMP or pre-calculated backup path in a time frame that is independent of the number of prefixes. The last one is the microloop avoidance. It basically, again, leverages segment routing to avoid microloops during network conversions or reconversions. Slide number 3. I'll talk first about the TILFA draft on behalf of the list of authors who are listed here. Slide number 4. So currently there are 2 discuss points. The first one is the use of should keyword. It is I'll address each one of them. Should is used 5 times in this draft. Maria and John, and I think Gunter also commented that I should have justification for every should. There are many RFCs that do not provide justification or explanation for should, and these are 2 examples. And these 2 drafts, for example, are referenced in this document. The second discuss point is the use of the keyword key, which is only used 1 time only. Let's go to the next slide. I discussed the should keyword and how to address them. Slide number 5. Okay, so it is used twice in section 6.2. And it basically talks about the case where a remote node is in both in the P space and the Q space. And the paragraph suggests that the repair list should just be the node SID of this PQ node. And I suggest that we change it as follows. When a remote node R is in the P and the Q space and is on the post-convergence path, the repair list can be made of a single node segment to that remote node R, and the outgoing interface set to the outgoing interface used to reach R, thereby minimizing the size of the repair list while keeping the repair list on the post-convergence path. So this way, you avoid the use of the 2 shoulds in this particular paragraph. Slide number 6, in section 6.3, it talks about the case where there are 2 nodes, P node and a Q node, that are adjacent. They are both members of the P space and the Q space respectively. In this case, the paragraph suggests that the repair list should be made of 2 node segments, or 2 segments. One of them is the node segment of the P. The first one is the node segment of the P node. And the second should be the adjacency segment from P to Q. And I'm suggesting that it would be changed to Again, when a node P is in the P and a node Q is in the Q space, and both are on the post-convergence path and both are adjacent to each other, the repair list can be minimized by keeping the repair list on the post, and while keeping the repair list on the post-convergence path by constructing it from two segments, a node SID towards the node P, followed by an adjacency SID from P to Q. The last use of the P node, and that's slide number of the should word or keyword, is in slide number 7. This is in section 9, and I'm not going to read the entire paragraph, but section 9 talks about flex algos. And what I'm suggesting is changing the keyword should to may. And I changed the last sentence a little bit, that if, so basically the idea is if you want to protect using the flex algo, just use the flex algo in all your calculation. The last sentence, I changed it a little bit. If an implementation uses the constrained SPF algorithm bound to that flex algo, then the implementation must only use the node SIDs bound to the flex algo and or the adjacency SID that are unprotected, or in case of segment routing of SRv6, adjacency SID that are bound to this flex algo to build the repair list. That's pretty much what I'm suggesting to solve the should problem. This way, I don't have to provide justification. Slide number 8 just talks about the keyword or the key word. So John interprets key as a must or mandatory, which is, it's only used once, by the way, in the abstract. And the document mentions many times that the document that being on a post-convergence path is not mandatory. As I showed here, and at least in these few paragraphs, is also mentioned multiple times before. And there was a quotation from dictionary.com that is mandatory, so I replied with a quotation from Merriam-Webster that it is not mandatory. So that's the only thing. I can change this key to very important or whatever. I don't think it's worth the argument, but the point is that the document is very clear that the post-convergence is not mandatory. And that's pretty much the discussion about this draft. I can go to the next draft or take questions on this draft. It's up to the chairs to decide what you guys want me to do. Should I move to the next draft, the BGP pick draft? There's only one item then. Okay, I'll move to the next slide.
Just a second.
Yeah, is there a question?
Jim Guichard from FutureWay. So Ahmed, obviously, I'm the responsible AD for this document, and I've been watching it closely. And I think we need to have a conversation. So my suggestion is we get on the phone with John, because you know, frankly, I don't think it's as obvious as you make out on the slides here. I think you know, John does have a point. I also looked at the definition as well, and frankly, it's a little bit ambiguous. So I would like to have that conversation, and we can do that outside of this, so we can hopefully move the document forward. But I think the discuss is, you know, that they need to be resolved before I can move this forward. So let's have that conversation.
So the conversation is about the word key. Is this what is it about?
Yes, because I think there's confusion between, you know, is it mandatory, is it not mandatory? And certainly it's a fair point to say, you know, as an outsider, if you read the document for the first time, it isn't clear, at least from my perspective. And so that's where this discuss comes from. So we need to make it clear. And,
it is,
you know, I understand. Yeah, I understand, Ahmed. I mean, if you've been working on a document for a long time, you've made a lot of changes, it's very clear to the author. But as somebody coming in from the outside, reading the document for the first time, I think it's fair to say that that it could be confusing. So I would like to see it cleaned up so we can remove that confusion.
The document mentions maybe 10 times that it is not mandatory. In fact, some of the
understood.
paragraphs.
I'm just saying that.
What is the confusion there? Is the word key, so I can just take it out saying very important, for example? Would that clear the confusion?
Well, I mean, it's not my discuss, it's John's discuss, and I don't think John's here. So, let's have that conversation outside of here. But sure, I do think that maybe removing that is the right thing to do. I don't know, to be honest. I think we just need to have that conversation and clear it up. I think going backwards and forwards on emails not helping. So let's try and get on the phone or something like that, and we can clear it up between all of us.
I'm actually, to be honest, I'm quite surprised that the document mentions 10 times, including some of the quotations that John himself put, saying that while it is not mandatory, and then there is still a confusion that because John, if you look at the email, John quoted places from the draft that it says that it's not mandatory, but there is
no,
still...
I understand, Ahmed. No, and I'm not going to, I'm not trying to be argumentative. I'm just saying that this has been going on in terms of email exchange backwards and forwards, and we're not getting anywhere. So let's try a different approach, and get together, and we can clear this up. So
I would argue, my question is what is the wording suggestion? What is it that everybody wants? What John wants? The problem is John is putting a lot of like saying, oh, there is an inconsistency. What is it that you want? That's my question. Anyway, yeah, sure, we can have a phone call. I tried that a few times, but he was busy, and frankly, I was quite busy myself. Anyway, any question? I see Stuart. Stuart is there. Stuart.
Hello. So, Ahmed, when this piece of work started, many of us have tracked this piece of work since the first day it was presented at the IETF. And when it was presented, the word key was important because it was a fundamental concept of the design that the repair path had to follow the post-convergence path. And the document kind of has that sort of subtly written in various places, except in the places where it doesn't. So I think what the authors need to do is to be quite clear to the working group. If it is no longer key, if it is no longer a mandatory, a requirement to follow the post-convergence path, there needs to be an explanation as to why this position has changed, and then the text body needs to reflect the consensus position of the working group on whether it is important that it follows the post-convergence path, or it's not important, or there are times when it is and times when it is not, and in which case those circumstances should be documented in the text.
So the document clearly says that it is not mandatory, and it is important, and it explains why it is important. Like, I can read part of the document and I'll point them out. Actually, I'll reply to your email. But the point here is that we don't really try to put justifications, because then I will go into the details of the implementation. I just put the spec there and say, you know what, it is important, but it's not mandatory. You don't have to follow it. Your implementation doesn't have to follow it. If you want to follow it, I have paragraphs that says how you follow it in certain scenarios, like the case of overlapping.
And I think it does need to. I think you're skipping the important point. The original thesis was that this was a required congruence. That has been dropped. The least you need to do is to explain to the working group why the requirement for congruence has been changed. And then we need to decide what text needs to go in the document to reflect that change of position. But absolutely, this was a fundamental of the original design, and it seems to have been quietly and subtly changed without explanation.
Okay, so I thought it's, yeah, I can add a statement. That's why it is, I thought it's obvious, basically, because some platforms cannot do it. It's as simple as that. I'll put the sentence if this is why it has been dropped. This was basically a feedback that we got. I can try and dig the emails. It has been a long while, that some hardware simply cannot support it, or some software cannot support it. If the length of the SID stack is long enough, hardware cannot support it. So you can still do topology independent, which means you can still get your backup path, but it will not be over the post-convergence path. That is the only reason, really. You can add this.
I think this probably needs a longer conversation than we can have in this working group, and I think Jim probably needs to convene a group of experts.
Okay, sure. Yeah, it would be great. Sure, I'm available. Okay. Sasha, yes, please.
Sasha, you are next in line. Please try to be quick. We are running out of time.
I just wanted to say exactly what Stuart has said. I have nothing to add. The situation when something is called the key aspect of a feature and then called non-mandatory is not creates a confusion, to put it mildly. This has to be resolved one way or another with explanations, because there is a lots of history behind this change of requirement. I second what Stuart has said.
Okay, sure. Okay, I think I got the point. So I'm open to discussions. I have no problem really. Okay, sure.
Ahmed, do you feel we need another discussion on this? Is it clear what the working group is expecting from you in terms of changes and clarifications?
Yeah, it's my understanding, and again, I'm talking about Stuart and Sasha's comments, that the original draft was, I have to dig it out, to be honest, it's been a long while, that to meet the ILFA, the repair path has to be post-convergence. This has been dropped from must-have to important, and I avoid shoulds because of the pushback that I get. But in my opinion, it should be a should. But it seems like the Sasha and Stewart want it back, and not only Sasha and Stewart, there are other persons who exchange email privately, but because it's private, I'm not going to divulge their names, that also think that it should be put back to mandatory. And I'm open to either way. Either you guys want me to put it back as mandatory, or say why it is not mandatory. I have a reason why it is not mandatory, and I just mentioned it, and I can put that. I'll discuss it with the co-authors and see what they want. But I understand Stuart and Sasha's comments.
Okay, so please focus on what needs to be done rather than history and whys and who said what. It's clear that as feedback, please do address it. Okay, let's continue.
Yeah, sure. Yeah, thanks a lot. Thanks. Okay, should I go to the next slide? Yes. Slide number 9. Oh, it's not moving. Oops. I skipped the slide. Sorry. Slide number 9. I'm talking about the BGP PIC draft on behalf of the authors. Slide number 10. So that was a very long discussion, and the main contention point, which was raised by Alvaro, is that the terms have to be consistent with BGP PIC, with BGP. And frankly, I don't understand why. First of all terms are unambiguously defined. If there is a term that is ambiguous, I'm more than happy to clarify it. Second, the terms describe functionality that is used in a different place on a router. Like the functionality that I'm describing, and is very clear from the abstract, that I'm describing a forwarding plane behavior. I'm not describing a BGP behavior. Okay. And in fact, you don't have to have BGP to have BGP PIC, and you don't have to have BGP PIC to have BGP. They are really two different things. The last thing, which is the term consistent, I really don't know how to make things consistent. So I am moving basically towards closing this consistent discussion, because it is really not relevant to the BGP and BGP PIC are describing two different functionalities in two different places on a router. All terms are well defined. So I'm asking the opinion of the working group. Other comments I will address. Go ahead. Go ahead, Yingzhen.
This is Yingzhen from FutureWay. So speaking as a working group member, Ahmed, if there is a term that's already defined in RFC 4271, I would think you should use that term instead of inventing a new one in your document.
So the 4271 describes BGP. I am describing a forwarding plane behavior. Since BGP spec does not describe forwarding plane behavior, there is no way I can reuse the term. If I use it, then I'm describing something else. You see what I'm saying? So it's somebody can point me, and I would be more than happy to say that this term is identical to the definition of term X in your draft is identical to the definition of term Y in 4271. I will go ahead and use that term. But the point here is that this wasn't defined. They are very well defined, all of them in the terminology, and I would love somebody to point to say, this term X is identical to term Y in the BGP spec, and I'll go ahead and change it. But what I'm seeing now, it doesn't exist.
as far as I remember the comments, there was a few obvious one that you can reference existing document. We can take this offline.
We can take this offline. Again, if you point this out, I'll go ahead and change it. It's just a replace. So I'll take me 3 minutes to do it. But basically, I want to make sure that I don't reuse a term from RFC 4271 that has meaning A for meaning B, or semantics A for semantics B. That's my main point. Okay. Any questions on this draft other than Yunzen's questions? Sasha, I see Sasha and Jim again.
Yeah, so Ahmed, it's Jim. I'm obviously going to pick up this document, so I haven't seen the previous reviews, but just one thing to consider. I don't know if there was a list of terms that was given in previous reviews that are of concern. So if there are, if you want to send those to me, I can certainly take a look. I'd be happy to.
Okay. I'll send the list of terms. Okay, to Jim. Okay, sure. I'm taking notes actually. Thank you very much, Jim.
Sasha, are you in the queue or you forgot to remove yourself? Ahmed, please continue.
Okay, actually, I just have like a couple of slides. Slide number 11. Micro loop avoidance on behalf of the authors who are listed here. I actually, to be honest, I don't have status for it. I did not have time to work on it. I was mainly working on the TILFA. It took a great deal of time, and BGP pick. But mainly, recently, I was working on the TILFA draft. I had to basically work out each and every detail. So I don't have stats on it. Once the BGP pick and the TILFA draft are basically move out, then I can work on this. It shouldn't be much effort. Hopefully, we will not have to go into the discussions that we went in the TILFA draft. And pretty much that is what I have. Thank you very much for the questions. Thanks for the comments. And I'll mute myself if nobody has any questions.
Ahmed, for the last one, we have been hearing people asking about the U-loop avoidance draft. Do you really have to wait until you close the other two?
Okay, to be honest, it depends on how busy I am. Chances are I will not have the time to work on all three in parallel. I'm just being frank with everybody. Definitely, I will try to close on the BGP pick and the TILFA drafts as soon as possible, and then once I'm done, then I'll switch to the micro loop avoidance. To be honest, I just have to be very honest with everybody. I will not have the time to do that.
So, well, I think we agree to help you with the BGP pick terminology. So maybe
Sure.
that can help move things a little bit faster.
Okay, sure. Yeah, sure. Yeah, maybe I can start working after I come back from IETF. Probably the week after the IETF, or the week after the IETF. Not in the IETF itself. Yeah. Okay, sure. That would be great.
So please do remember, after the draft is accepted by the working group, it's the property of the working group. So
I understand.
Yeah. So going back and forth, arguing about terminology, it's not a time well spent. I think the goal is to make document acceptable by all members of working group rather than trying to make your point. Please do cooperate.
That's what I did. That's what I did with the should. I said, okay, guys, you don't like should, I'll take it out. And again, key, if you don't like the word key, I'll take it out from the TILFA. I don't have a problem in taking things out. The only thing is that BGP pick, the terms are really different. I'm describing something different. But I'm open. I have no problem. I'm open now to changes. I don't care. Thanks, Jeff, for the advice. Thanks, Yunzen. Thanks.
Okay, let's go to the next presentation.
理论上是不是添了点？
Okay. Can you hear me?
Yes. There is a little bit echo on your side.
是不是别人给画了些什么样？
Okay, start. You can start.
Okay. Hello, everyone. This is Danny Jie from China Telecom. I'm presenting a new draft of segment routing based loop-free implementation on behalf of the other authors. What's the macro loop? An app network computes pairs after the distributed IGP protocols. If a node or link fails, a loop may occur on the network because LSDB are not synchronized. However, such a loop disappears after all devices on the forwarding path complete conversions. Such a transit loop is called a micro loop. This document divides the scenarios that require anti-micro loop schemes into 4 categories. Take the scenario and the callback scenario, multi-source scenario, and multi-parameter scenario. Next, I will introduce these scenarios and the anti-micro loop schemes. The first one is the target scenario. Target macro loop refers to the macro loop caused by node or link failures. As shown in the figure, when the link between router 3 and router 5 fails, it is assumed router 3 completes convergence first and router 2 do not complete convergence. There may be a tangent macro loop happening between router 2 and router 3. The anti-macro loop scheme for target scenarios consists of 4 steps. Phase 1, hold down time 1 is configured on router 3, which is the neighboring node over the failed node or link. And the router 3 use TIF FA forwarding for the duration of time 1. Phase 2, a hold down time 2 is configured on the remote node and node forwards traffic to router 3 for the duration of time 2. Phase 3, time 2 time out, the remote node returns to normal convergence firstly. First, 4, time 1 time out, router 3 will revert back to normal convergence. The second one is callback scenario. Macro loop may occur not only when the node or link fails, but also after the failure recovery. And shown in the figure, the failure link between router 2 and router 3 is recovered. And there may be a callback macro loop happening between router 2 and router 4. It's only necessary to insert any under-exit from router 2 to router 3, and the path from router 4 to router 6 is guaranteed to be loop-free. This one is multi-source scenarios. When an IPv4 or IPv6 prefix advertised by multiple nodes in its domain, the prefix has multiple router sources. SRv6 multi-source macro loop prevention minimal use SRv6 under X and under seed as the label stack for multi-source macro loop prevention. SRMPRs minimal uses the prefix seed and adjust seed and the label stack for multi-source anti-macro loop. and that's all. There are different scenarios and different implementation schemes for loop prevention. We will update the draft to end multi-point failure scenarios and other scenarios. Any feedback and comments are welcome. Thanks.
Peter?
Here, Peter Pshenak, Cisco. Well, my question is, what's the purpose of this draft? It describes a local implementation. It's a local behavior on a box. There's nothing that's needed for interoperability. So I understand this is the informational draft, but I'm just asking, do we want drafts like this?
Our draft describes some different schemes for different scenarios. I think using different schemes for different scenarios is more targeted. For example, since the network do not enter the TIFA forwarding process after the failure is recovered, the delay convergence cannot be used in the callback scenarios to prevent the generation of macro loops and the technical scenario.
I'll try to reiterate Peter's point. So draft doesn't introduce any new extensions that require for interoperability. So we're all for informational best practice documents that describe operational experiences. Most of functionality you describe has already been defined in IETF and most cases implemented. It would be very useful if besides describing all the cases, you would also have clear pointers to existing IETF, RFCs and drafts that are more mature than this document to point out this is where it's defined, this is where you can find the definition. So in combination with your own experience as an operator, for example, it might be very useful for people to read and understand why we did particular work and how it has been implemented, right? But otherwise, there is nothing really, I understand it's informational, but please use references to existing documents to really explain if you want the draft to be useful.
For example, how you come up with those time, the number of seconds you define using those timers. Sasha, you are the next. Please go ahead.
I also noticed that the track this draft is not specified. I have also sent a comment to the author that they should try to consider looking up RFC 5715. This is an informational RFC about framework for loop conversions, which explains many of the investigates multiple techniques that could be used to achieve loop-free conversions in various scenarios. Some of them are. It also provides some estimates regarding what is and what is not feasible to implement. One of the examples from in the draft clearly uses something very similar to what has been published as RFC 8333, which introduces a local delay at the PLR. Defines very clear condition, very clear scheme regarding how this can be done. So, effectively, I would say that I concur with Peter, who has spoken before me. I don't understand why this draft is needed. What it is going to define, to stand in, it doesn't seem to be standardizing anything. The solution that it, from my point of view, that it special case presents can be have all been described one way or another in other documents. So I don't know. I'm not sure why this is needed. Sorry, say that.
Sasha, to reiterate the point, sorry for interrupt, you're describing technology that has already been described in other documents. If you want to make it useful, make sure you're referencing it, you're not inventing anything new. And if you have operational experience, this is what would make this document useful. Otherwise, reiterating what's already been stated, it's not very useful. Okay?
Hello, everyone. I'm Chanwan Lin from H3C. I will present this draft. This draft is about pass-aware remote protection. In the version 2, we add new 2 co-authors from Juniper and Broadcom. So background, current IP network protection mechanisms could be divided into local protection and end-to-end protection. Local protection such as ECMP or LFA or TIFA, and end-to-end protection could be used to monitor for end-to-end TE paths. There are several scenarios such as spy leaf-based DC network could not cover the, for example, early the BP protocol deployed and IPB-based forwarding, not TE. So, for example, well, in the link between SPI2 and the leaf3 failures, and the leaf1 still send the traffic to SPI2 until the control plane converts. It will be waiting a long time for the control plane to converse, while BP has a large number of routers. So the basic idea is the device leave to respond the remote link failure, and then response and invoke the faster repair path. Here is the existing mechanism for route converse in current DC network. The converse of the local failures handling includes the local detection and the local fast switching time, usually taking tens of milliseconds. The converse of remote failure handling time includes the local detection and the fault notification and the global fast switching time. Typically takes a few seconds depending on the amount of BP router. Let's take a look how the pass-aware remote protect worked. It considers 3 parts. First part, the routing control protocol. We need to extend the routing control protocol to carry and generate the remote path information. Then in the report table, we need to corresponding the local next hop with the remote path info. The second path, For the forwarding table, we need a corresponding direct next hop with the remote path info. The second step, when the failure occurs between SPI2 and the leaf 3, the SPI2 will send the failure message to the remote routers, and then the leaf 1 will receive the remote failure and response to this message and find the next hop which remote path failures, and then switch to another usable path. Here is our framework. It considers 3 components. The first is path-aware routine play. This routine play responsible for generate remote path information. The second component is the forwarding play. The forwarding play should include the local next hop and corresponding to the remote path information. The third component is about the remote failure detection. When the failure, when response to the remote failure, and then invoke the fast repair. Here is the current routing and the forwarding play, and compared with the path-aware routing and forwarding play. The current routing and forwarding plays for SMP routers in forwarding table, each prefix corresponding an SMP group, and the SMP group may corresponding many next hop, multiple next hop. For path-aware routing and forwarding plays, we need to expand ISP or BGP to carry the remote next hop path information, and then the fiber and the RIB table will be extended to corresponding the remote path information to the local next hop. For example, for the SMP routers in forwarding table, each prefix corresponding SMP group and SMP group corresponding multiple next hop. Each next hop corresponding remote next hop information. The remote failure detection consists of two parts. The first part is to detect the local failure. It can use the BFD or use can monitor the traffic drop count in the static. And then the second part is send the fault notification. The fault notification should have the following requirements. It must be independent of routing protocols, and it is easy to implement on hardware, so it can achieve the millisecond or microsecond notify. Finally, this is a simple use case. These 2 routers are established EBP peers, and the router 5 send the BGP routers to router 2, and the router 2 can use the draft the one IDR next hop and next hop node to carry the next BGP next hop. So the router 2 send the router to router 1 with its local next hop and the next hop. So in the router 2, it will corresponding the local next hop to the remote path next hop. And then when the link between loud 2 and the loud 2 and the loud 5 failure, we can use the draft Zhang RTGWG router info to fast notify the failure message, and then the loud 1 can respond the remote failure message and can find the next hop which the remote path failure, and then respond quickly to switch the route to another available path. Yeah, that's all. Thanks. Any question, comments are welcome.
I have a couple of comments, say working group chair. So the document would benefit from better explanation of scenarios in 3-level or more level leaf spine networks, where you have more than one hop to traverse.
It focused on DC network.
I understand, but most of DC networks have at least 3 levels of switches, not 2, right?
Yeah.
So it would be very useful if you describe it. Number 2, you are talking about BGP-only data centers. Probably would be useful if you mention RFC 7938, kind of explain how it works. I think what's not clear from reading the draft is that you are signaling in extensions you proposed a router ID, while in BGP in data center you use eBGP, where your BGP session is actually on the link, right? So you don't know the correlation between router ID to next hop, or you need to build another layer of hierarchy. You also need to make sure that router IDs are distributed. Another way, someone needs to redistribute loopbacks, which is not always true. So all of this need to be addressed in the draft.
Yes, thanks. We will add this consideration in next version.
Thank you.
Yeah, thank you.
Maria, please go ahead.
Maria, developer of BERT. I'd like to ask you 2 questions. First is sorry, I am IPv6 maximalist. Why are you using public IPv4 addresses with no documentation purpose in your schemas and in your figures on the slides? But the other thing, much more substantial, is aren't we just reinventing the wheel? Is this not solvable by improving the performance of BGP implementations? Because what I can see here is just adding a workaround to a problem which can be solved in another way for which we already have existing solutions. Thank you.
Yeah, thanks. I will respond in the mail list. Thanks.
Peter, you're next.
Peter Pshenak, Cisco. So I just want to second your comment, Jeff, that this works if the failure is 1 hop away. Is this solution limited to that case?
Yeah, it's limited in the spy leaf network. It just use the DC network and no deployed TIRFA, and usually in AI training network.
Okay, well, I believe there may be multiple hops still even in the
Yeah,
DC.
you need to specify your
And
topology.
if that is the case, make it clear in the draft, please.
Yeah, we will update next version. Thanks.
Ajun, please go ahead.
Yeah, Adrian from China Telecom. I want to ask a question regarding to the failure notification mechanism. You know, there is already some mechanism within the IGP protocol, and currently you mentioned the scenario for the BGP scenarios. So, but for the failure notification, you mentioned the BGP independent protocol. So I want to What's the reason you select the BGP independent and not extend the BGP to transfer such failure information?
In DC network, the BP is maybe the first choice. IGP is not usually deployed.
Yeah, I know. But in your slide, you have defined you have mentioned another solution for the traffic trend router info proposal. It is BGP independent. I want to ask why you select the BGP independent protocol to transfer the failure notification.
Oh, yes, the failure should be independent of routing protocol. So it can, if it used the existing root protocol, it can't achieve the millisecond or microsecond.
Yeah, but regarding the if you do not select the IGP or BGP, you must require the router to support other protocol to transfer the failure information.
This draft will be presented this morning, and you will discuss later.
Okay, thank you.
Yeah.
Alex, please be quick.
I think it was Jeff Haas.
Jeff has, yeah.
Thank you. So 3 comments primarily focused towards the next top node stuff. So Jeff, your comment about, yes, we could actually use the next top addresses for the link, but part of the use case that was covered by the next top node stuff was the fact that addressing schemes sometimes won't have unique addresses, especially for certain types of link local types of data centers. So the choice was made in that specific draft to actually make it the BGP ID, which from a protocol perspective must be identical. You're correct that there's a mapping operation that may occur in some of the scenarios, but the mapping operation is fairly straightforward because it's based off of BGP adjacencies on a given system. Second comment is to Maria. Part of the problem is that you're making an assumption that BGP global convergence, even in efficient stacks, can actually work at the speeds that we're looking at. That is not generally the case. BGP is just not a terribly well converging protocol as much as I love it. The third case is the speaker is mentioning the router info draft that's going to be presented and shown on the slide here is the local detection mechanism that's being discussed. Thank you.
Yeah, thank you.
Hello, Alexander Azimov, Yango. So if we're speaking about this infrastructure, and normally we don't have a V4 there, we have V6 address family. To solve the problem that you are describing, we already have TCP stack and flow label that provides a way for fast rerouting whatever happens in the network.
I can probably respond since I'm familiar with what you're doing. It's over the top, right? So I think they are orthogonal to each other. And if your transport layer can decide there's an issue, can decide to change entropy or do something else, which is kind of orthogonal to network convergence. So again, it's been deployed, but it's orthogonal to what we're discussing.
Yeah, sure, but it just addresses that the reaction is too slow. No, in reality, the applications not suffering from this kind of slow reaction.
Yeah, okay, thank you.
Thank you. Please continue the discussion online.
And for clarification, what Alexander was describing is a solution where transport layer can provide enough information that there's a delay or failure in the network and change entropy, hence avoiding fail path, heuristically at least.
Good morning. I'm David, and this is destination source routing, which you might have seen before. And if you have, then you can zone out because nothing has changed about this draft from last time. We did find an editor for this. Shu agreed to do that, which I'm very thankful for. Shu is on Meet Echo. He could not make it. If you have questions, you can ask him there as well. You have probably seen this before, I hope. It's a very old draft. It came from HomeNet. People keep asking about it in weird random places, most recently about source address selection. So that is why it got revived. I hope I don't need to explain too much, but here is a short summary. Routes have a source prefix with this, not only a destination prefix. You start with the most specific destination you can find. You try to find the source under the routes that have that destination prefix. If you find something, you're done. If you don't, you do need to go up to less specific destinations, but only after you didn't find it as a source. All of this is specified for IPv6 only because we don't care about IPv4 anymore. The behavior if a route has a default source prefix is the same as classic routing. So any route that is not a destination source route is equivalent to a destination source route with a default source prefix. All of this describes behavior. This is not an implementation guide. You probably don't want to implement it by doing the loop that I just described by going to less specific prefixes. This is intended if you have a consistent routing domain. You don't want to partition your network into different VRFs or zones or policy or whatever. That is really key here, and that is what drives the fact that you're doing a destination prefix lookup before going into detail on the source and then backtracking. If you want to do any kind of zoning, you want to do the opposite thing of that. And it is very important to understand the distinction. If you actually want to implement this, you don't want to do the loop, as I just said. You can synthesize artificial routes to get to the other view if that's how your hardware works. You can do multiple tables and fill them in. This draft specifies only the behavior that is visible to the routing system. It doesn't tell you what gates to put in your ASIC or what code to write in your forwarding plane. This is referenced, well, it originally was referenced in the Babel specification for destination source routing that is now in RFC. The reference had to be dropped to get that published. That was 3 years ago at this point. We did have OSPF-v3 and the ISIS drafts for this. Both of those expired, and if there is sufficient interest, we can revive those and get back to implementing that. Someone also tried to do this for BGP. I'm not sure that ever was posted, but all of this depends on what people want to do with this. The entire point of this draft is to document all the common parts that apply to whatever routing protocol you stuff this in. If you want to do any kind of redistribution of routes between protocols, without this, you're really in a bad place. And there are non-obvious considerations when you do, when you add source prefix to the routing lookup. And that's described in this document. If you're interested, please read it. All of this is implemented and has been implemented for a very long time. As a matter of fact, Linux has implemented this 8 years before the draft was even begun. That 2006 there is something. It is also implemented in a research network in China who it's referenced later. They updated OSPF-v3 to re-add the capability to exchange routes for this, and they implemented it on Tofino chips to put it in hardware. You can do a lot on Tofino. This is one of the things. There are control plane implementations, of course. Both Bird, FR routing, and BabelD implement this as shipped. You don't even need to patch anything. It's just there. FRR never merged the ISIS implementation. You can still dig it up if you choose to do so. Yeah, this is used in the Future Internet Infrastructure Project, who have actively deployed this. It's a research network, to be clear. They're evaluating what happens when you do this, using it for load balancing, access control, doing multi-homing, doing FRR. If you have questions about this, Shu is in Meet Echo, and we can bug them about it. And you can go buy an OpenWRT router. the kernel feature is enabled by default on these routers. Depending on what exactly you buy, you may or may not get the packages that do the control plane for it. This is the somewhat ill-fated HomeNet stuff. You can still find it, it's still there, you can still run the code. And yeah, we do have recent, yet another thing that is referencing this. If you've been following the infamous rule 5.5 for source address selection, it says that you try to use a source that was advertised by the router that you chose. So lots of discussion, and it turns out if you do this, you may actually want to have destination source routing on your end host, because you are selecting a source address, taking a particular router into consideration. And while the source address that you selected is going to persist after you establish the connection, the routing choice, it hopefully is equally sticky. It's not necessarily the case. If you have a very poor implementation, you can shoot yourself in the foot by implementing Rule 5.5. I don't think such an implementation exists. However, if you do destination source routing on the end host, this really makes Rule 5.5 work very well, so to speak, because you get the capability to bind things together as they have to be to get your packets to the correct router. Yeah, already said this. The idea here is that you create destination source routes from the arrays that you receive by using the PIO in the route as the source prefix. This is not described yet in the draft. As I've said, there were no changes from last time around. That is one thing I'm looking for feedback on. Do we want to put it in this draft? Do we want to have a separate draft for that? Do we not care about it at all? And yeah, that was speedrun mode. Questions?
Alexander, you're in the queue.
Are you in the queue for questions or? Okay.
So thanks to reviewing the work, and it's important.
Hello, everyone. I'm Xinxin from China Unicom. And my topic is deep collaboration between the application and the network. So in the digital age, there are the users have the higher requirement and the different requirement for their services. Maybe they the users hope their servers can be smooth and stable and higher quality anytime and anywhere. For example, there are new scenarios such as the Internet of Vehicle, massive data transmission, instructor internet, and so on. They have different requirements for both network and computing services. For example, remote driving requires lower delay, and the automatic controller need the deterministic delay. For the data sharing between the enterprise, the secure and the stable capabilities is necessary. But now application and network operate independently and are unable to interact to provide the flexible and efficient resource scheduling. So I will introduce some typical scenario for to explain the importance of the collaboration between the network and the application. The first is the Internet of Vehicle. In this scenario, vehicle should need to be communicated with other vehicles, instructors, and cloud services. There are two types of the applications. The first is the applications affecting driving, such as the autonomous driving and the remote control and the intelligent driving services. They may require the extremely lower network delay. They can provide the quick judgments and the responses. The other type, the application is unrelated to the driving, such as the voice or other entertainment services. They is not sensitive about the delay, but they may require the higher computing performance. So we need to identify the different service applications to provide the different capabilities. The next scenario is the massive data transmission called the MDT. So in this scenario, the users maybe need to the predictable completion time. Before the starting transmission, different tasks have the different the demands of their data and the completion time. So the network needs to provide different capabilities for that. And also, we need to identify the transmissions data in order to avoid affecting the other servers in the internet, in the network. After the transmission task is initiated, network devices need to identify MDT application and the corresponding account of the information based on the center identified to perform a traffic record. The next typical scenario is the industry internet. There are so many different applications in this scenario, just like the industry control and the radio surveillance and the remote robot operations. There are different requirements. For example, the industry control task requires the system to respond within a strict time. So the network needed to provide the lower delay, and the radio surveillance need the transmission of the large amount of the radio data. So the bandwidth is important, and for the remote robot operation, it is required the real-time transmission of the controller instruction and the feedback. So maybe the network need to be systematically delayed. The next typical scenario is the data sharing and circulation. Now, some enterprise or hospital or the bank need to transmission the data between them. But these data are often involved in sensitive information. So it is necessary to identify the sensitive level of their data. And in order to the network can be control the scope of the data transmission. So about this analysis, we think yeah, if we can do the application and the networks for the deep collaboration, we can have the benefits. First, the network resource and the application requires can be dynamically and accurately matched. And also, the stability and the user experience of the application will be improved. and the utilization efficient of network and the computing resource can also be enhanced. But how to improve that? We think there are two issues we need to do. The first is the process awareness of network status by applications. Yeah, and the other is the awareness of applications requirements and the status by the network. So they need to their deep collaboration each other. In order to solve these issues, we think we should do something for that. The first, how to do the network awareness by the application. We need a current measurement of network indicators and across cloud measurement, and the obtaining of the measured network indicators by applications. And for the application awareness by network, we need fine-grained awareness of the application requirements and the computing status awareness of the server applications. Finally, I will introduce the deployment case. This is the Internet of Vehicle solution we had implemented in the China. And in this deployment case, we realized the network awareness of the application requirement and the computing resource status. And also we realized the application awareness of the network status. And these pictures are taken in the deployment case. So it is the remote driving scenario. So in this case, we can provide a higher quality and a more flexible solution for the Internet of Vehicle. So that's my presentation, and any comments and suggestions are welcome. Thank you.
Jun?
Yeah, Adrian from Taiwan. I think the application that you mentioned is very interesting, and I think you may know that there will be one side meeting in tonight to discuss how to export the network capability to the cloud or to our application. So I think if we can export the capability of network and we can make the application and the network collaboration very deeply. So I think we can discuss more in tonight's side meeting.
Okay, that's very good.
Okay, Daniel Huang, ZTE. Thanks for this presentation. Would you please turn back to the slide about mass data transmission? Yeah. You mentioned just the application side needed to be aware of the network links to the bandwidth capabilities, something like that. But from my understanding, I just want to clarify, is it there's, what you mean is the coordination between the application and network, or the coordination between host and network? Because it's the massive data transmission actually is about more about the coordination between host and network.
Yeah, we think the massive data transmission is corresponding the network, and also the application is the related.
Okay, thank you.
Yeah.
Jeff's working group chair. So we've been having this kind of presentations over a couple of years. I would really like you to focus on making this work relevant for the working group. So as in our charter, we are happy to actually present your use case first time with high level, somewhat marketing material, but if you want to present second time, it must be relevant to the working group. Otherwise, you're not going to get time anymore, okay?
Okay. I will to propose some detailed solution in the next chat, not just the requirement.
Thank you.
Okay, thank you.
Okay, let's go to the next presentation. Thank you.
Morning, this is Izholi. I'm going to present in this draft, talking about some considerations for the routing in computing cluster network. Okay. So here I show a very brief topology here for the computing cluster network. Excuse me. It consists of multiple computing cluster pods. So there are a lot of flexibility how the operator or the owner to design their cluster pods. It could be like something like a rack server, multiple racks, and even some bigger clusters. So I just put here as a very rough indication here. So it could be different topology from the very commonly known as the tree, or could be something like a torus. But one thing to take note here is, although there are multiple topologies available for a single cluster pod, it's not like hundreds of them, or even not the tens of them. It could be a few of them, like 3 or 5, something like that. At the same time, it may not be a single one. So that's the key observations we have here. And from the leaf to the spine, although I put the factory or class structure here, it could be something else as well. So the whole picture here shows that this is a rough indication for computing cluster networks. So to summarize, what are the key features here? Oh yeah, because the font is too small. Okay, so there are some well-known characteristics I listed here. The first one is normally it's quite large scale, and let me see here. Normally it's large scale, and we all know multiple paths are available, and either equal cost or unequal cost. The second well-known characteristic is here is the prior knowledge of the topology is known. And the third one is the owner or the operator of such a network normally expect that it can provide a high bandwidth and low latency for very large data volume. But here the very large data volume not necessarily mean it's like a big file transfer. It could be like a burst of data volume, then stop for a while, like an AI traffic pattern. It could be, it's also possible. Then the last one, but not the least, is the high modularity. Here, the modularity means the cluster pod could be a single structure or topology, or it can be repetitively used for the multiple pods. And also different structure also can be possible, but the modularity is there. So some of the key considerations for such kind of network is the scalability, availability, and like the failure handling, also the complexity of the network configuration and maintenance. So I will quickly go through this page. The routing in such a network, there are 2 directions of them generally. The first one is a distributed routing. The second one is centralized routing. And there are a bunch of papers out there for each of them. So generally, we know for the distributed routing, it can achieve good scalability and flexibility of the policy control. But normally, the people have concerns for the heavy configurations and the slow routing convergence caused by like the per node calculation or propagation of the information. And centralized routing, or sometimes called SDN-based routing, it has the pros like it can provide a global view and more easily to find out the optimal routing path, and the configuration for each of the single network node is light. And also normally there is no routing calculations on a network node, but there's some variance of them. So the cons of the centralized routing is the operators have concern of the scalability, and there is normally an out-of-band control network which introduces another source of failure, and the exception handling may not be very efficient. So it gives us a question that is there any good way to combine them, to combine the advantages of both in order to achieve the enhanced scalability at the same time of the improved resilience and optimized performance in such computing cluster network. We find out basically that there's some emerging trend we call the hybrid routing. Here, just one example we took from the paper. There are a bunch of papers, so I just take this one as one example. It's called the Primus. So it's trying to combine the advantage of both the centralized and the distributed routing. There are two pictures here. Actually, they're trying to solving the same problem. So I just focus on the left one. The key design here is the red box is, let me see here. The red box is something like, it is affected switches. So it tries to report to the lead. Lead here is, we can consider it as a SDN controller. But unlike the normal SDN-based routing solution, the SDN controller does not do the calculation for all the network nodes here. It tries to inform the affected switches, which is yellow boxes here. The yellow boxes will do some of the computation, but it's not as heavy as those distributed routing because the computation could be based on some pre-installed topology and rules. So that's the way one way to combine two approaches, two types of approaches here. So this is the last page. Some inspirations and potential work we see here is the hybrid routing could be one of the possible way for the computing cluster network. There are different approaches for hybrid routing from research area, but despite how many of them, mostly they include at least the two key aspects. The first one is what's the most appropriate way to divide the routing functions between the controller, centralized controller, and the individual network nodes. And the second one is how to fully use the prior knowledge, including those topology information, the paths available, or even the traffic patterns, and also the modularity information of the computing cluster network. For example, there are different variants of the approach, like a regular address allocation, or some pre-calculations or predefined rules. So that's all different ways to fully use of them. So there's a very starting point of this kind of work. The next step from us is we were trying to revise the current draft to elaborate the common ground of different ways of hybrid routing, mostly from the research. And we are considering to propose a new draft to cover the overall structure of hybrid routing and what could be the potential future work in IETF. We are thinking this could be a good match for RTGWG as an incubation for the AI or data center networks. So if you're interested, you are welcome to join us. Either drop me an email or talk to me in the hallway. Thank you.
Thank you. Tony?
Hi, Tony Lee, Juniper Networks. I'm pleased to see that you're considering thinking about link state information. Yes, that is key to making things more scalable. Have you considered simply using a link state protocol?
You mean simply use the current link state routing protocol?
It does everything you've listed.
No, as we see here, from the research and from different sources of information, okay, let me see, where is it? Okay, Yeah, so the traditional distributed routing, for sure, it has a good thing of the scalability, but at the same time, we required a heavy configurations here. And also, if the failure from the remote, it will propagate it at each of the node will do the computation by itself and hop by hop, something like that. So this is what can be overcome by the centralized routing or by some variants of the implementations of the merge of the both.
The faults that you've listed here are the result of using BGP in the data center, a tool for which it was never, ever designed to be used. So, you know, you might want to consider that the faults of IGPs are somewhat different. They don't have the level of configuration complexity of BGP.
Oh. So in that case, you are suggesting that we should, I mean, you are suggesting the IGP is the best fit here?
I'm suggesting that you consider it because the faults that you're trying to avoid are BGP specific.
Okay.
And as far as I can tell, the link state IGPs are about 99.9% of the way along to you're meeting your goals.
Oh, okay. So I guess the point taken. So maybe we will try to cover the IGP case in the next revision here
Thank
in
you.
order to make it clear. Yeah.
And there also been comment from Jeff House. There's a working group called SVR that does BGP with link state extensions to it.
Okay.
Thank you.
Thank you.
Please
So,
consider.
Hello, can you hear me?
Yeah.
Yes, please go ahead.
Mm, hello everyone. I am Zhongpeng Du from China Mobile. And, this slide is about in-network congestion notification mechanism, and it's a 0 version. And this is about during IETF 118, TTE mechanism is introduced, and it's about tactical traffic engineering. It's a kind of real-time TE, different from traditional TE. And in the mechanism, when a link is nearly congestion, some traffic along the link will be steered to a backup path. For example, the P4 and the P6 in the finger, they are adjacent nodes, and when the link reach the upper limit link utilization rate, the TTE mechanism will be triggered, and some traffic will be steered to a backup path. However, it is a local policy for two adjacency nodes. In the provider network, the traffic usually is paired by some tunnels between PE nodes. For example, the PE1 and PE2. And this document want to involve TTE in the provider network and to make the network load balance. And this page about TTE for the tunnels, we assume that there are two tunnels between PE1 and PE2. The primary path is tunnel 1, and the backup path is tunnel 2. And if the link between the P1 and the P4 is nearly congestion, the normal procedure of TTE can trigger the path of traffic following tunnel 1 to be steered to tunnel 2, so as to avoid potential congestion. However, if the link between P4 and P5 become congested, we need a notification method to announce the P1 to do the traffic steering, because the tunnel may be based on the source routine method such as SRv6. I know that there are some protection method for the link failure. However, in our scenario, we do not care about the link failure. it is about the link congestion. And this page is about the main method of the draft. It's called the in-network congestion notification. We have the same assumption. When the P4 and P5 is nearly congestion, the P4 will mark some packets in the tunnel 1 as ECN11 in the outer layer IP header. And the P2 will receive the ECN11 and return ECN01 to the PE. The P1. The P1 can receive this ECN01 and trigger the TTE for the tunnel 1. The about ECN11 and ECN01 is all on the outer layer IP header, which is invisible to the client and the server. So we call it in-network congestion notification. And the ECN11 is on the forward path with the source address and destination address as P1 and P2. And the ECN01 is on the related reverse path, for example, the tunnel 3, which is not shown on the figure, with the source address and destination address as PE2 and PE1. And this last page, and welcome for comments and contributions. Thank you. Welcome for comments.
Any questions? If not, thank you for saving us a few minutes. We are way behind our schedule. Okay, we'll go to the next presentation.
Hi, chairs. How can I turn? Oh, okay. Okay. I just can you hear me?
Yes, please start.
Oh, okay. Ladies and gentlemen, good morning. Thank you for gathering here today to listen to our presentation on the progress of the draft of Adaptive Routing Framework. I am Zhuang Rui from China Mobile. Firstly, I will briefly introduce the motivation of the framework for adaptive routing. The current AI network exhibits the following characteristics: a low number of flows, but each flow has a very heavy load. The commonly used load balancing strategy employs an untuple hash algorithm to forward traffic on a pole flow basis. For current AI networks, such load balancing strategy can easily lead to load imbalances, causing network congestion. When network congestion occurs, current load balancing adjustment strategies usually require nearby devices at the congestion point to switch links based on the local link congestion state. However, the adjustments made by device near the congestion points have limited effect on transferring traffic and elevating congestion, making such approaches inefficient. Therefore, the key idea of adaptive routing framework is to enable load balancing adjustments to start from the earliest routing devices, thereby significantly improving the efficiency of load balancing. So, for an adaptive routing mechanism to achieve even load distribution, per flow load balancing and per packet load balancing could be performed. To accurately detect congestion on each link, each device could perform congestion detection, including link-based detection and flow-based detection. And upon detecting congestion, notifications should be sent to the remote devices to perceive congestion at earlier nodes. And respond to these congestion notifications. Congestion adjustments could be performed by adjusting path weights or path loads, or by redirecting flows. In the latest version of this draft, the main updates are as follows. First, this draft has undergone several changes, including modifications based on the comments and feedbacks from IETF 120. Second, the scope of this document has been clarified to focus on adaptive adjustment on multiple loop-free passes. Noting that the generation of multiple loop-free passes is not covered within the document. Third, we add a definition of congestion in the new version of this draft. On this page, we list some comments from IETF 120. Their main concerns focus on how to quickly and effectively detect and handle congestion and remote link failures. We have 3 operating modes for handling the above problems. The first one is weight-based dynamic ECMP flow adjustment mode, which periodically receives congestion states from the remote link and dynamically adjusts the load distribution weight. The second one is flow redirection mode, which redirects part of the congested flow and is suitable for scenarios like AI training, where the flow is regular. The third one is packet-based adjustment mode, which requires endpoint support for ordering. Each packet is forwarded via the link with the least load. The proposed adaptive routing framework consisting of 4 parts: routing plane, forwarding plane, adaptive routing policy, and remote congestion detection. On this page, we introduce the design details of routing plane and forwarding plane. Since this content has been discussed in IETF 120, they do not require further repetition here. Adaptive routing policy is responsible for dynamically adjusting routes according to remote link congestion information or flow information and updating the forwarding plane. Adaptive routing policy could be categorized into flow-based and packet-based adjustment. The flow-based adjustment mode could be further divided into 2 types: weight-based dynamic ECMP flow adjustment and flow redirection-based adjustment. Remote congestion control is responsible for detecting link congestion and sending congestion notification to neighborhood devices. Congestion detection is generally performed by devices near the congestion point, including the detection of link congestion and congestion clearance. Network performance and congestion points can be identified by sending text traffic, monitoring query depth, and monitoring packet loss rate. But the specific congestion detection methods are beyond the scope of this draft. So we won't discuss it in detail. The definition of congestion can be based on the interface bandwidth of forwarding buffer utilization, measured using a quality level. The quality level can be calculated based on current bandwidth and buffer usage, and can be tailored so that lower levels indicate poor path quality. Here we list a simple example. And then when a change in congestion states is detected, it needs to be communicated to remote devices to adjust traffic scheduling from the source. There can be 2 types of congestion message. The first type includes path information, which includes the congestion information of links corresponding to the path. Global congestion calculation can be performed with this information. The second type includes the 5-tuple information of the congestion flow. Congestion flow redirection can be implemented with this information. The congestion notify can be achieved by extending the IGP protocol to transmit link state information within the IGP domain, or by extending the BGP protocol and setting up BGP reflectors to facilitate communication between BGP neighbors. How to adjust the frequency of sending congestion notifications and processing congestion message to improve the performance of adaptive routing is a problem worth studying in the future. Up to now, multiple chips and vendors have implemented our adaptive routing framework. On this page, we list the chips and or vendors that have implemented our framework, including Broadcom, Juniper, and Conware V9 from H3C. They all support weight-based dynamic ECMP flow mode and packet-based adjusting mode. And Conware V9 from H3C supports flow redirection mode. And we are going to search for further supportment and achievement from the chips and vendors. So that's the end of my presentation. Thank you so much for attention. And any question or comments are welcome. Thank you.
Yeah, Adrian from Untitled. Because to lessen the congestion, listen, congestion status. So I want to ask, what's your consideration?
Presenter, maybe it's still set, but you need to turn off the volume.
I assume someone's mic in the audience.
Yeah, you need to turn off your own mic.
Okay. So I want to ask one question. What's your consideration to avoid the traffic oscillation? That is, if you move some traffic from one link to another link, then maybe the destination link may be congestion again. So how you to avoid such situation? Okay.
Are you going to answer?
Okay. Maybe you can
thanks for your question. Thanks for your question. The adjustment should be gradual and not too large in magnitude. So if there is a clear identification of accident flows, we will use flow-based adjustments. But if there are too many flows and hard to
maybe take it to the list. Thank you.
Thank you.
And
Thank you. Next
and hard to scheduling, we can consider using packet-based or packet-based adjustment, or with more small gratitude.
Please continue the discussion on the list. We'll go to the next presentation. Thank you. You have 8 minutes.
Okay. I'm coming again. Xinxin from China Income, and my topic is generated IPv6 channel. So this work had some discussion in the previous meetings, and we do a lot of work in the previous past time. So mainly focused on the why we need to do this work. So for this meeting, we will intend to improvise on the scenarios and requirements discussion, and also to solicit opinions of the moving forward work. So we will introduce some typical scenarios. The first is the private line. In these scenarios, the enterprise may need end-to-end insert OM across the whole private line. Maybe which need to combine the wide area network and the data center network to the measurement and the troubleshooting. Especially in the service function chaining scenarios, a path might in or out the cloud multiple times. This can makes the troubleshooting extremely challenging. And also, the wide area network and the data center network probably use different technologies. For example, the WAN use the SRv6, and the DCN use the VXLAN. And also, we know the VXLAN maybe does not support some new features like the IOM. So the DCN segment of the private line is not to support the features. There is some problems in the end-to-end scenarios. And the second scenarios is also the Internet of Vehicles. Just like my previous presentation, we do the deployment in the network in these scenarios. to realize the collaboration between the network and the application. But in the deployment process, we found some problems. Because we need to do the end-to-end IOM across the whole connection, which combine the radio access connection and the wider area network. But between the base station and the UPF, there is a GTP tunnel, and this tunnel is does not support advanced filters such as IOM and slicing. And slicing is also needed in these scenarios because we need to distinguish flows. For example, we need to distinguish the medial streaming flows and the remote driving signal flows. So in these scenarios, the GTP tunnels make the prominence to the end-to-end. And the third scenarios is the SD-WAN. Yes, it's the same story. In these scenarios, GRE tunnel is existed. But the GRE tunnel does not support some new features. So we also have the problems to realize the end-to-end IOM or the slicing. So for about this analysis, we can know there is some IP tunnels in the network, and also have many IP tunnels defined and in different network, such as the VSLAN, GRE, IPv4, IPv6, and so on. So how to enable advanced features in the legacy IP tunnels? Maybe we have two choices. The first, we can extend all these legacy IP tunnels one by one. For example, we can extend the VSLAN to support the IOM, or we can extend the GRE to support the slicing and so on. But there is very massive, lower efficient work. And maybe the second choice, we can define a common IPv6-based tunnel for the much better future-proof extension. So we proposed the solution is the generalized IPv6 tunnel called JIP6. This is defined to use the IPv6 header and the IPv6 extension header to support the new features while presenting legacy IP tunnels. So there is two options. We recommended the option 1. And if we can use the JIP6, there is some benefits about the scalability. Any new functionality in the subsequent IPv6 header extension can be inherited by the various channels without having to define them separately. And also, we have the efficient encapsulation, and we can remove duplicated fields. And also, there can be flexibility about the native compatibility with IPv6 or the SRv6. So flexible programming of the end-to-end path with future new features. So we need to clarify something. We propose the JIP6 is not to redo all the work in the active tunnel technologies. For example, MPS is already support plenty of advanced features. We do not to redo that. But JIP6 can be create a common future-proof version for the scenarios that utilizing legacy IP tunnels, but need to enable modern or the future capabilities. So maybe we want to move forward the scenarios and the requirements work in the RTG work group, and maybe we can consider that core adoption of the requirements draft. And also, we will do the encapsulations work in detail in the 6-man work group. And that's my presentation. Thank you.
Any questions, comments? Okay, thank you. We still have one more presentation to go in the interest of time, so. Exactly 5 minutes. Go.
I'll be very quick. So I just jump to the goals and non-goals. So we have seen several presentations in previous and this IETF why we need this. So our goal is to have a generic way of and simple way to flood routing information very quickly and outside the routing protocol. It's easily and easily extensible. We have in our 00 version, we have proposed this UDP-based flooding mechanism. It has optional authentication header, including the source router ID, link ID, and the sequence number, and then followed by the TLVs, repeated TLVs. You could have a neighbor path information TLV, which is identified, which includes the per neighbor records. In the per neighbor records, you would have neighbor ID and then encoded info. You can also have link info TLV that includes repeated per link records, which is identified by link ID and followed by the link info. So in the previous version, when the link encoded info, we only have defined value 0 to indicate if the link is or the path is up or down. And in this new revision, we defined the new semantics for that. So there is the U bit indicates if the link or path is up or down. And then we have 4 quality bits to indicate the quality of the path or link. So that 4 bits gives us 16 levels of quality. For example, if value is 4, then it means that up to 5/16 of the total bandwidth remains. And that is used to notify the link loads information or congestion information. We removed acknowledgement option because we believe that refreshed advertisements remove the need for acknowledgements. And if you have critical information that you really need to make sure it gets across, then you can use bursty refreshes at the very beginning, and then you can slow down after that if the state does not change. Besides, if you really want to do the acknowledgement right, then we believe you would need to burden of adjacency and session management, which we don't want to do. So there have been some mailing list questions, and I didn't get to reply to in time. Apologize for that, but before the IETF meeting, I replied. So we looked into the possibility of using LMP or layer 3 discovery or something like that. I forgot what exactly it means. We believe that it's not a good fit for our purposes because they both require adjacency and session management, and they are not designed for fast stateless advertisements. There is one clarification I want to make here. At least in so far, we do not consider reflooding. When you get an advertisement, you do not reflood it out to other links. Not that all routers will get a flooded advertisement. It's only you only flood it to a neighbor. But the one half flooding could be an overlay hub. So for example, you could flood it to all the PE routers. Or you can even say that I really want this certain information to be flooded everywhere. Then you can use multicast. So all the routers be join a multicast tree and you flood your information on the multicast tree. But there is no flooding, or there's no reflooding. We will have some additional considerations for additional TLVs for additional flooded information. We will have two new co-authors joining us, Jeff and Yi Song. We still need to beef up the security considerations, especially about the TTL handling. And then we want to seek more discussions and comments and suggestions. Thank you.
I have one question as a working group member. You need to assume current data center topologies where there are super spine groups, so in other way, on spine level, there's no state merge. So practically the only place where states do merge are leaves. The rest is completely disjoint. So you need to figure out how to make this information usable without really reflooding it.
I somehow cannot hear you clearly.
I'll send an email to the list.
Yeah.
Oh, okay. All right, thanks.
Maybe you should consider not use the word flooding instead, because you.
Okay. Yeah. Well.
You are not really doing flooding.
Yeah.
Okay. Got it. Okay. Yeah.
If there is no further questions, I think we are done with today's session. Thank you, Jeff.
Thank you so much, everyone, and see you in
Bangkok.
Bangkok. Yeah.
Yeah.